For centuries, humanity gazed at the night sky and wondered, are we alone in this vast cosmos? On October 19, 2017, astronomers at the Pan-STARRS telescope in Hawaii detected something that would begin to answer that question in an unexpected way. An object was moving through our solar system at 87 kilometers per second. Too fast. The wrong trajectory. When they calculated its orbit, the computers gave an answer that had never been seen before: a hyperbolic path. This object was not orbiting the sun, it was passing through from another star system. The first confirmed visitor from interstellar space. This is the story of how we found them, what they taught us, and what they tell us about the universe beyond our cosmic neighborhood. Every planet, asteroid, and comet in our solar system shares a common origin. They formed 4.6 billion years ago from the same cloud of gas and dust that created our sun. They are gravitationally bound, trapped in elliptical orbits, endlessly circling the star that birthed them. Their eccentricity, the measure of how elongated an orbit is, ranges from near zero for circular orbits to just under 1 for the most extreme ellipses. But an interstellar object is different. Its eccentricity is greater than 1. That means a hyperbolic trajectory. It is not orbiting, it is visiting. But how do we know it came from another star? The mathematics are unambiguous. These objects formed around different stars, perhaps billions of years ago, in molecular clouds hundreds or thousands of light years away. Ejected by gravitational interactions, close encounters with giant planets, or stellar flybys, they have been wandering the galaxy for eons. For a few months we can study them, a brief window into distant star systems we could never otherwise reach. Our galaxy contains 200 to 400 billion stars. Each one is potentially surrounded by planets, comets, and debris. Some of that material gets ejected into interstellar space. Occasionally, one of those wanderers passes through our system. Oumuamua. In Hawaiian, a messenger from afar, arriving first. When astronomers had time to analyze the data, they found something unexpected. Its shape, based on how its brightness varied as it tumbled, was elongated. It was roughly 400 meters long, but only 40 meters wide, 10 times longer than it was wide. Nothing in our solar system looks like that. Its surface was reddish, similar to objects in the outer solar system that have been exposed to cosmic radiation for billions of years. And then things got strange. As Oumuamua sped away from the sun, it accelerated slightly, beyond what gravity alone could explain. With comets, this is normal. When ice vaporizes, the outgassing acts like tiny rocket engines, pushing the comet. But Oumuamua showed no coma, no tail, no visible outgassing, yet it was accelerating. Harvard astronomer Avi Loeb proposed a controversial hypothesis. What if it was not a comet? What if it was a light sail, artificial technology from an alien civilization, pushed by sunlight like a sailboat catching wind? The elongated shape could be a thin, flat object. The acceleration could be from solar radiation pressure, not outgassing. Perhaps we had just witnessed humanity's first detection of extraterrestrial technology. NASA and most astronomers disagreed. Too many assumptions. Outgassing can be invisible if the composition is unusual, perhaps releasing gases that do not scatter light. The tumbling motion could result from natural processes. There were simpler explanations that did not require invoking alien civilizations. But here is what nobody disputes. We discovered it too late. By the time we knew it existed, it was already leaving. We had weeks to observe something that may have been traveling for hundreds of millions of years, and we will never see it again. It is now beyond Neptune's orbit, heading back into the darkness between the stars. August 30th, 2019. Crimean amateur astronomer Gennady Borisov was scanning the sky with his homemade telescope when he spotted it. Another interstellar visitor, but this time we were ready. This time we caught it earlier. 2I Borisov, the second confirmed interstellar object. Immediately, telescopes worldwide turned toward it. What they saw was reassuring. Borisov looked like a comet. It had a visible coma, a cloud of gas and dust. It had a tail streaming behind it as solar wind pushed material away. Spectroscopic analysis revealed water vapor, carbon monoxide, dust, the typical ingredients of comets from our own solar system. No anomalous acceleration, no mysterious tumbling, no controversy, just a comet from another star system. But Borisov gave us a gift, time. Because we discovered it farther out, still approaching the Sun, we had over 6 months to study it. Hubble captured detailed images. The Atacama Large Millimeter Array measured its chemical composition. Ground-based telescopes tracked its evolution as it warmed. And what we learned was profound. Comets in other star systems form the same way comets in our system form. The laws of physics, the chemistry of planet formation, they are universal. Borisov came from a star system perhaps hundreds of light years away, formed billions of years ago, yet its composition was familiar. The building blocks of planetary systems, it seems, are the same across the galaxy. We are not unique. July 1st, 2025. The Atlas Survey Telescope in Chile detected object C 2025N1. Within days, orbital calculations confirmed it had a hyperbolic trajectory. Interstellar. It was the third confirmed visitor, 3I Atlas. From the beginning, it was different. It was larger than Oumuamua and Borisov combined, estimated between 4 and 5 kilometers across. When the James Webb Space Telescope analyzed its coma, astronomers found something unusual. The gas was dominated by carbon dioxide. Most comets are rich in water. 3I Atlas was not. As it approached perihelion, its closest point to the Sun, on October 29th, spacecraft at Mars captured close-up images. The Mars Reconnaissance Orbiter photographed it from just 19 million kilometers away. European Space Agency orbiters tracked it, refining its trajectory with unprecedented precision, improving the predicted location by a factor of 10. This was the first time that measurements from a spacecraft orbiting another planet had been officially accepted into the Minor Planet Center database. By November, astronomers were worried. The comet was brightening rapidly, faster than typical comets. Its color was wrong, bluer than the Sun, when dust should make it redder. Astrophotographers captured images showing a complex tail structure, multiple jets fanning out in different directions. And like Oumuamua, it showed non-gravitational acceleration. NASA maintains that it is a comet with unusual properties. The high carbon dioxide content could indicate it formed in a very cold region of its original star system. The rapid brightening might be explained by fresh ice being exposed as the comet rotates. The unusual color could result from the specific composition of the dust grains. But Harvard's Avi Loeb points to the anomalies, the rapid brightening that exceeds most Oort cloud comets, the strange composition, the trajectory that lies almost perfectly in the plane of the planets, statistically unlikely for a random interstellar object, the non-gravitational forces that seem too strong for the amount of visible outgassing. On December 19, 2025, 3I Atlas will make its closest approach to Earth. Still 270 million kilometers away, too far to threaten us, close enough to study intensely. Hubble will observe it. Webb will analyze its composition in detail. Ground-based telescopes worldwide will photograph it. Amateur astronomers with 8-inch telescopes will be able to capture images of this visitor from another star. And then, like Oumuamua and Borisov before it, it will leave. Forever. By March 2026, it will pass near Jupiter. By the early 2030s, it will have left the planetary region entirely. In about 8,000 years, it will pierce through the Oort cloud and return to interstellar space, continuing its journey through the galaxy. 3 interstellar objects in 8 years. Oumuamua, Borisov, 3I Atlas. Based on these detections, astronomers estimate 1 to 2 interstellar visitors pass through the inner solar system every year. But we only detect the ones that come very close to Earth. We're missing most of them. That's about to change. The Vera Rubin Observatory in Chile, now completing construction, will scan the entire visible sky every few nights. Its sensitivity and coverage will increase our detection rate by 10 to 100 times. We'll find interstellar objects earlier, farther out, giving us months instead of weeks to study them. We'll build up a statistical sample. We'll learn how common these objects are, what they're made of, how they vary. But we are building something different. The European Space Agency is going further. In 2029, they will launch Comet Interceptor, 3 spacecraft that will not head directly to a target. Instead, they will park at the L2 Lagrange point, 1 million miles from Earth, and wait. When an interstellar object is detected approaching the inner solar system, Comet Interceptor will fire its engines and intercept it. This is not just observing from Earth. It is actually flying to it, meeting it in space. 3 probes will separate, photographing it from multiple angles, analyzing its composition with spectrometers, and potentially even collecting samples. We will not be passive observers anymore. We will be active explorers, chasing these visitors, meeting them on their way through. This is a rapid response mission, waiting in orbit, ready to pursue whatever comes next from the stars. Oumuamua, Borisov, 3I Atlas, 3 messengers from distant star systems, visitors carrying information about worlds we'll never reach. Each one taught us something about planetary formation, about the chemistry of distant molecular clouds, about how common or rare our solar system might be in the cosmic landscape. They passed through quickly. We barely glimpsed them, but they are not the last. Our galaxy is filled with these wanderers, debris from billions of star systems ejected eons ago, drifting through the void. Most will never come close to us. The distances are too vast, but some will, and when they do, we'll be waiting. Not just with telescopes on Earth, but with spacecraft ready to chase them, to meet them, to learn what they can teach us about the universe beyond our small corner of space. Estimates suggest that 3I Atlas may be 7 billion years old, older than our entire solar system. It formed when our sun did not even exist yet, around a star we cannot identify, in a region of the galaxy we cannot pinpoint. It has been traveling through interstellar space for longer than Earth has existed, and for a few brief months in 2025, it passed close enough for us to see it. 3 visitors so far. Billions more are coming. We're learning to listen,